Students, in this session we are going to discuss about the various unconventional machining process which was used for fine surface finishing work. Abrasive jet machining, water jet machining, abrasive water jet machining, or some of the equipment used in the unconventional students, we are going to discuss about the various unconventional machining process. Abrasive jet machining. Abrasive jet machining is a machining for abrasive particles are made impinges on the particle and remove the unwanted material. The machining process works on the basic principle. So the diagram shows about the abrasive jet machining process. The schematic diagram shows the abrasive jet machining. Working principle of the abrasive jet machining: first, gas or air is compressed into the compressor, that density. Working the high pressuring abrasive carried gas sent to the nozzle where it is pressure energy. The various applications of the abrasive jet machining is: next one is the water jet machining. The process works on the basic principle of water usage. So the line diagram shows about the equipment connections. So water jet machining can be working summarized as follow. First, water is impinged. The high pressure water now sends through the tubing system to nozzle. The water passes through the water jet machining, it is applicable for drilling, cutting hardened material. Abrasive water jet machining of the equipment showed in this diagram. Abrasive water jet machining is mainly used for small holes or many fine removal. Abrasive water jet machining application: cut, virtually machined. Abrasive cutting. So it is abrasive cutting is used for remove the or making the cutting. So next one is the ultrasonic machining. Ultrasonic machining system. So ultrasonic machining, we utilize the very narrow or very small minute work. So in mechanical material removal process used to erode the material in the form of fine particles. Ultrasonic machine rays. Ultrasonic machine is done by the ultrasonic rays. Small amplitude or high frequency of vibration are given to the tool, typically in the range of 10 to 20 micron. Mechanism: material removal. Although the ultrasonic machining process is commonly used, the basic ultrasonic equipment consists of the following element: generator, acoustic head, etc. Acoustic head, the tool used in the design to provide the maximum amplitude of the vibration. Abrasive, common type of abrasives: iron carbide, silicon carbide, corundum, etc. Advantages: machining material regardless of their thermal conductivity. Disadvantages or limitations of ultrasonic machining is: soft material like lead and plastics. Application: ultrasonic machining process. So next operation is electrical discharge machining. So the schematic diagram shows about the electrical discharge machining. It is known as the spark machining or spark eroding process. So electrolyte used dielectric fluid, the optimum gap. So properties: low viscosity, remain electrically and non-conductivity up to the desired voltage breakdown. Properties possessed by the tool: it may possess high melting point, electrically conductivity. The schematic diagram shows the electrical discharge machining. It is consists of the various parts: fixer, table, workpiece, tool, dielectric modem. And then working of electric discharge machining is dielectric container by means of a fixer. The tool and workpiece are separated by the means of the dielectric fluid, and then positive ion are attracted towards the negative ion and the negative ions are attracted. The same procedure is repeated to remove the material from the surface. Advantages of electrical discharge machining. Machining process does not limitation. Working material must be electrically conductive. Perfect square corner holes. It is for the producing hole size less than 0.1 mm. So electrochemical process. Electrochemical machining is the one type of unconventional machining process. It is characterized as reverse electroplating, means it removes the metal by means of the both electrical and chemical processing. DC power supply is used here. The weight of the substance produced during the electrolysis process is directly proportional to the process. So the schematic diagram used is the cathode is tool, anode is the electrically conductive machine. Process, power supply, electrode, it depends upon the electrode working. So the process is shown is with the schematic diagram. Main subsystem, power supply, electrolyte, tool, the control system, workpieces. Electrolyte, commonly used electrolyte or sodium chloride, sodium nitrate, sodium hydroxide, sodium fluoride. The most commonly used tool material or copper. The control system control parameters include voltage, inlet and outlet pressure, etc. Workpiece should be conductor of electricity, so it is almost limited to metals only. Further specialized application, die sinking, profile and contouring, trepanning, grinding, drilling operation are done with this help. Different application of electrochemical machining. It is economic and product. The process is economical when large number of complex identical products are used. The advantage is ECM is well suited for the machining complex two-dimensional shapes. Next one is the plasma arc machining. So in this we are utilizing the plasma rays. It is consists of processing, what are the equipment, parameters influencing plasma arc machining, etc. Plasma arc machining is the material removal process. The material removal takes place by very minute. So mixture of free electron positively charged ion and neutral ion obtained. So heating the gas to a high temperature ionize the gas is popular method. When the gases are heated, the following can occur: elastic and inelastic collision between the atoms. The schematic diagram easily understandable for the plasma arc welding. Plasma arc machining process. The plasma arc machining consists of power supply, DC power supply. The DC power supply should have saturation. Gas flow rate 2 to 11 meter cube per hour, controlled by using the mass flow rate. So plasma torque. Electric arc consists of from nozzle generate with the images of various nozzle utilized for various plasma arc machining. Various methods, plasma torches, parameters influence the design and operation of the torches, the physical configuration of the setup, the evaluation, operation aspect, design aspect, and plasma torch is very minute general design consideration, large current require, larger diameter electrode, orifice length. So the successful utilization plasma machining is necessary to analyze the following process parameter: power supply, size of the operation we can do, etc. So the tabulation shows the what is the